for a couple of the questions on the test. Um, uh, Given the triangle below, find sine of theta. So sine is the opposite side divided by the hypotenuse side. And they ask for our answer as a fraction, or they might say the exact answer, or as a ratio of two integers, or a ratio of side lengths. Those are all saying that we're not supposed to do decimal approximations. They want our answer to be of this format. Okay, the opposite divide by the hypotenuse. So that would be the answer to this question. Okay, just so make sure you're not typing in like the decimal approximations with a calculator or something. This question is asking us to use ideas of trig functions that we know to help us rewrite this. A lot of times in later on mathematics, we're not interested in trying to find one exact answer. We're interested in rewriting a formula to help us, solve a different problem or help us prove a different formula. So this question is asking us to rewrite this, not to say what sine of 13 pi over 12 is. But when they say write sine of 13 pi over 12 in terms of sine of a positive acute angle, you can graph where 13 pi over 12 lands. So 13 pi over 12, that's a little bit more than 1 pi, right? So that's in the third quadrant, probably more acute of a reference angle than that. That means sine is going to be negative here, okay? Sine is going to be negative. So what we could do is we could say that reference angle is pi over 12. Sorry, I'm writing with a computer mouse. The reference angle there is pi over 12. So if we wanted a right sine 13 pi over 12 in terms of the sine of a positive acute angle. Acute angles are the angles that are only here. So we could do this and have the same ratio if it's the reference angle pi over 12. But to compensate, we know that this would evaluate to be a negative value for sine because sine is only positive in the first and second quadrants. Sine is negative in the third and fourth quadrants. So we need a negative sign out front. Okay. And then you could prove this works for yourself if you were to draw, if you were to evaluate what the opposite, use the hypotenuse of 1, do your sine ratio here, and then do the same thing, make a triangle with pi over 2 as the reference angle, then do your sine ratio, and you'd see that it's they're both the same thing if you use that negative sign on the outside. Excuse me. Okay, that's it for that one. Again, this one is probably an answer format for some of you, but we're supposed to say what cosine of theta is. So what you can do, whoops, I lost my, there we go. Theta goes to the point square root of 10 over 10, so it's positive on the x-axis, positive on the y-axis. That dot maybe is somewhere up here, and theta, the terminal side of theta goes through that point. So this is our theta. And then we're supposed to say what cosine of theta is. Cosine is the adjacent, so that would be the x-axis, square root of 10 over 10. Sorry, that's a 10 up top inside that awful square root. And then the opposite would be the y, the 3 squared to 10 over 10. So you got to find the hypotenuse in this situation. So if you do that, it's a squared, which I've done here. I squared the top and the bottom, plus b squared. So that's 3 squared makes 9. 9 times 10 makes 90 over 100. That equals c squared. So we got 10 plus 9 makes 100. 100 over 100. You square both sides, so the hypotenuse is 1. So if we're supposed to write cosine, we just leave it as the square root of 10 over 10 for our final answer here, because cosine is the adjacent divided by the hypotenuse. So square root of 10 over 10 is what you'd want to write for your answer, not the decimal equivalent. Okay, let's get rid of that. 2 more here. Same thing for this one. When you try to evaluate cosecant, and enter the answer as a fraction, so you could say like whatever you think cosecant is supposed to be using the definition of cosecant, like 15 over 8 or 8 over 17. Leave it as a fraction. Don't convert it to a decimal. Terminal side of an angle in standard position measuring 11 pi over 36. First thing to note I'd say is that that's acute, right? Because pi over 2 would be 90 degrees. It's a little bit less than pi over 2. So 11 pi over 36 goes here. my drawing. And actually, I don't want to draw this way because they say that we're. Well, let me just make a big note here. Answer with an ordered pair in terms of the variables x and y. Our answer has to have x and y somehow. Okay, so this is an ordered pair of x and y. That could be our answer. But the question that they're asking is, hey, there's this new angle that's 61 pi over 36. Look, that's almost 2 pi, right? That's 1.69444 pi. So that's an angle that's over here. That's why my first drawing was wrong. And if you compare that to 2 pi, if you compare that to 2 full revolutions around the circle, 72 over 36 would be 2 pi. So if you subtract 2 pi by the angle that we're given, we get 11 pi over 36 over here for a reference angle. So it's the same reference angle. 11 pi over 36. Okay, it's the same reference angle, so it's going to make the same trig ratio. But the difference is, so it'll intersect the same numbers, absolute values of the x and y coordinates. But for this one, x is positive, but my y is negative. That's what they're trying to get you to say with this problem. Okay, they have the same reference angle, except when you do SOHCAHTOA, that's going to change some of the values because now the y is no longer positive y, it's negative y. So that's what I type in for my answer for this question.